Welcome to another episode of Network Forensic Fundamentals. Once again, my name is Phil Hagan, and in this episode, we're going to be talking about another one of the core tools that's an important part of the Network Forensicator's toolbox. This one is called tshark. Now, this is a command line utility that's actually a part of the Wireshark distribution. And in fact, it is another front end into the same back end that Wireshark itself uses. So in the last couple of episodes, we've talked about Wireshark. All those same capabilities and possibilities do generally have an equivalent function here at the command line using tshark. So again, remember, tshark, Wireshark, different front ends to the same back end worth of information, worth of functionality overall. Now, this is really important because it means almost everything you can do in the Wireshark graphical environment, you can also now do in the command line. Anytime we talk about command line tools, it's a very important thing for us as network forensicators to remember. This is because command line tools give us scalability and repeatability, because I can run the same command over and over and over again instead of needing a graphical tools workflow to run multiple times against different PCAP files, for example. So that's where the scalability comes from. And in terms of repeatability, it's because we can start to bake these functions into shell scripts or have consistent, repeatable command lines that we might add into case notes. So if we need to go back and revalidate findings, or if we need to go back and reaccomplish new searches across new evidence, we can use the existing workflow to make sure we're providing consistent results. Different evidence, same basic workflow. It's going to be useful for us overall because that repeatability and that consistency is really important as well. So lots and lots of different things that we can use this for, but what I really love is they gave us the display filter. So everything that we had just talked about in the last episode about the display filter functionality, we can now bring to the command line as well. Lots of great other things you can do here. And just as another reminder, Wireshark's own training is going to include a lot about tshark. There's a lot of other resources out there as well. There's some books. Nick Aline has a fantastic book about tshark. I will include a link to that in the notes here for you. Lots of other resources. So we're really just scratching the surface here. So let's take a look at what some of those command line parameters might be. Some of the command line parameters that you might run into are shown here. And again, not exhaustive. -R, -W, reading from a PCAP file and potentially writing to a new PCAP file. That becomes a really interesting possibility to use now tshark as a means of doing data reduction. We do have an option of using -N. This will prevent DNS resolution. Now, I also want to take a moment here to say that tshark uses all the same configuration files that Wireshark does. So if you remember a couple of episodes ago, we talked about disabling name resolution in tshark, and that being a recommended practice. If you make that change in the Wireshark graphical environment, it will also propagate out to when you run tshark. However, for me personally, I like a little bit of extra attention, a little extra reminders of how my tools are working, especially if it's something as important as preventing DNS resolution. Remember, of course, doing DNS resolution is going to both incur a performance hit as well as potentially operational security because those queries could be leaking out to the internet. So I want to make sure that visually, as I'm looking through a command line, I'm very certain that this is not occurring. So I'll always add in that -N as well. And another reason is a lot of times in my workflows, I'm pivoting back and forth between different tools. Let's say maybe TCP dump, and then tshark and going back and forth. Well, TCP dump, we said that it's an absolute must-have command line option to disable those DNS lookups. So if I'm going back and forth between tools, I don't want to accidentally miss one. It's a lot easier for me to just put the -N in every single time. If we want to use those display filters, which you probably do, those get added with the -Y option. I also recommend that you put these display filters in single quotation marks. It's going to help to protect that all those special characters you might have. Things like ampersands, pipes, parentheses. It's going to protect those from getting to the shell. And that's, of course, going to make sure that we treat that entire display filter as one element. So just little tricks that we've kind of learned over the years. But -Y is where you would specify the exact same display filter as we typed into Wireshark. In fact, I'll give you another little tip here. One of my most common workflows in this capacity is going into Wireshark, building the display filter, making sure it turns green, and then copying and pasting that off to tshark so I can put that on the command line. That way I already know it's going to work. It's going to at least compile. It's not going to throw an error. Our output can take a couple different forms as well, and the capital T option is going to let us specify that. By default, any packet that is read in that also matches the display filter will get a summary line very similar to what you see in the default packet listing panel of Wireshark. Remember, that's that multicolored list that we saw up at the very top of the window. So that's going to be the default, and that's just the text output mode. However, we also can add on the fields output mode. We'll talk about ways that that might come into to benefit you. You can output in PDML, which is a packet-specific structure using XML as Markdown. And a relatively recent addition is you can output that in JSON as well, which means now you could use JQ or any other JSON-aware tool to process the output data. Lots of options here for you, but of course this is going to depend on what your requirements are for your workflow or for your case. When we're in fields or JSON output mode, you might want to limit down what's being displayed. You might not want all of the fields from every single matching packet. And remember, each one of those fields is going to include 9 different timestamps. It's going to include all of the layer 2, layer 3, layer 4 packet headers, checksums, and other information. So one single packet might have several hundred fields in it when it comes to the way that Wireshark and tshark break those down. Usually, I want to limit those. And you can do this with the lowercase e option. So dash lowercase e is going to allow you to specify, here's the field that I want. If you'd like to have more than one field shown, you just add more than one lowercase e option. And each time you use the lowercase e option, you have to tell it the field name, which is in the same naming structure as we had in the display filters. So the example we had in the last module, the last episode, was http.response.code. That's what you would include in the -e option if you wanted to output that field, for example. You can put as many of these as you would like. And of course, as you put these into JSON format, it means you can also use other post-processing tools to kind of reformat or restructure the data. Fields output mode is going to be in tab separated value format or TSV format. You can then import that into a variety of other tools, but JSON is going to be inherently parsable with JSON aware tooling. And probably one of the cooler and least remembered, least understood of all these features is the capital G option. The capital G option is going to be the glossary, which means, hey, tshark, reach back into those Wireshark related backend libraries and give me a list of what you know. So you might say -G protocols. It'll give you a list of the 2,500 protocols that particular version of tshark can support. Or -G fields. It's going to give you a great big list of all the fields. Remember, that's 250,000 lines. So I'm probably going to want to grep that down to what I'm potentially looking for. So it's certainly not intended to be the final stage of research and lookups, but it's a great way for us to look at what that individual binary is able to know about. Let's take a look at a couple of tshark commands, and we're going to walk through each of these item by item to get an idea of what these command line parameters are doing, as well as how that might benefit us in an investigative workflow. In the first example, we're going to read in an existing PCAP file, and we're just going to print a summary row for any packet that contains an HTTP request using the post method. We start out with each of these just running tshark, of course, and you'll note that I'm not running these with any kind of elevated privileges because we're simply reading in an existing data file. We don't want to unnecessarily use sudo because that certainly does present somewhat of a risk. So the first thing is tshark, and as I remembered, my preference, my muscle memory is always going to use the -n option, and I'm reading in a PCAP file with the -r. Now I'm going to specify a display filter, and this is going to be a display filter to limit my output to just packets where the http.request.method field is equal to the post string. This is then going to return those summary rows because by default, it's going to use the text output mode. In the second example, we're going to be reading in the same file, but we're just going to be outputting tab separated value form of a couple of the fields that we're interested in. So we start out just like before with tshark, and then we add in a -n, again, just as automatic, reading in the same Nitroba PCAP file. And in this case, we're limiting our display instead of to what we had previously to just where the user agent field somewhere contains the string Safari. So we say http.user_agent contains, and we put Safari in double quotes. By the way, we can do this because the display filter itself is enclosed in those single quotation marks. So those double quotation marks will stay intact. Now, instead of relying on the default output format, I'm using the fields output mode, -T fields. And at this point, I can add on the fields that I would like to be included in the output. First of all, I would like this frame.time delta displayed, which gives us the number of seconds that have elapsed since the previous packet that matches this display filter. Then we add on a second one, -eip.src. This is the source IP address. Here's the user agent. This indicates I want the entire user agent string, which we know is going to contain the substring Safari, but now I'll get the entire user agent. And then lastly, the HTTP host, or what host name was in the URL that was notionally requested in the Safari browser requests. Each row will then contain tab-separated values of the time interval, the source IP, the user agent, and the host name. And then we can put that into a spreadsheet or do any other kind of analytics we might like. In the third example, we're actually taking advantage of a display filter as a means of reducing the data from the source PCAP file. So we're going to actually use a display filter, and we're going to now provide an output file. Start out with tshark-n, reading in the same nitroba.pcap file. And now with the -Y option, we're saying just any packets that contain an HTTP request. So the display filter is simply http.request. But instead of outputting information to the console or to the shell, now we're going to be writing out a new PCAP file. -W, this new PCAP file that's being created will only contain the packets that have an HTTP request. So we're doing a data reduction based on a layer 7 parameter with the HTTP request presence. And the last example that we have here is using the glossary function. I'd like to see the list of the entirety of all of those 250,000 fields, but I want to limit down what's displayed in the results to just anything line that contains the string user_agent. And I'm using grep, and in this case, I'm doing a case insensitive grep with the -I option. And this will then just limit us down to the handful of lines amongst all of those 250,000 that are containing that string somewhere on the line. I hope you were able to see a little bit of benefit of tshark and how that can potentially help you out. It's a really key tool for us, very important, very fundamental. It is one of those tools of last resort in casework because we want to reduce the data first. But once we have that minimized set of data, now we've got a tremendous opportunity with a layer 7 field and packet structure aware tool with tshark, just like we had within Wireshark. So scalability becomes possible, scripting becomes possible as well. And in the next episode, we're going to talk a little bit about some sample labs that you can go through on your own if you'd like to do so. And a part of one of those labs is going to be you leveraging tshark in order to reduce down the data based on the tshark functions. So hopefully you'll join us for that one as well and continue down the path. Once again, my name is Phil Hagen, and this is Network Forensic Fundamentals. We're glad to have you and look forward to having you back again sometime soon.